Hello, hi, good morning, good evening to all. Uh, we'll just start in a few minutes. Let's just wait for another minute for participants to join. After that, we'll start the session. Okay, so let's just start with the session. So I would like to welcome you all uh, to this wonderful meetup session on building Lakehouse with Apache Hudi. So yeah, first of all, before starting with this session, I would like to introduce you to our organization, Datacouch. So this session would be first of all taken by Sarfraz. He is a senior data engineer. But let me just quickly introduce you about what Datacouch is, what we are. So Datacouch is a team of consultants, data scientists, data engineers, experts, uh, trainers. Uh, we are a team of these, and we provide corporate trainings, consultancy services, staff augmentation services, and we provide browser-based solution, lab solution as well. With more than 150 years of combined experience, we provide trainings across various domains such as AR, VR, IoT, 5G, blockchain, digital twin, generative AI, data fabric, decentralized computing, semantic web, cybersecurity mesh. So along with that, we have trained more than 150,000 participants all over the world. Uh, we almost cover 75 plus different technologies while focusing on Web3, generative AI, big data, and many more latest or bleeding edge technologies like that. As I told you, we have industry experts which are globally renowned, and most of them are certified by any of biggest IT giants there in the market, such as Google, Microsoft, Confluent, and many more. So recently, we as organization won one global education partner for 2022 by Confluent. We also selected as the most recommended AI startups in 2021 by CIO Insider as well. And we are the first training delivery partner for Starburst Technologies. So Starburst is a technology that works in the field of data mesh. So it is one of those technologies. We have two meetup groups with us. One is AI Minds, and another one is All Things Data. So you can join these meetup groups to get notification about these kind of meetup sessions, and you can get up to date and join these valuable sessions. So now I would like to tell you about Sarfraz. Sarfraz is a senior data engineer and is currently working at Apta. In his past, he has also worked with companies like Walmart, Nokia. He has specialization in big data and analytics. And if I specifically tell about Sarfaraz, he is uh, a great he has a great knowledge about big data and big data engineering world. uh, he is currently working on some of the latest technologies in the field of big data, and you can connect with him on the LinkedIn profile. On his LinkedIn profile you can
మనం తీసుకుంటా ఉంటే నేను చెప్తాను సెటప్ చేయండి కాదు లేదు వద్దంటే ఊరుకోండి రైట్ తీసుకోండి.
Murli, if you have any questions, can you please mute yourself?
అదే అని నేను
So I would like to invite Sir Fraz to take from here and tell us about how we can build the lake houses using Apache Hudi.
Hey, thanks for the introduction, Harshit. Hi everyone. So as Harshit has already given my introduction, so I'm not going over it again. But yeah, quickly want to understand from this audience, how many of you have experience with Hudi, or you are totally not experienced with Hudi. If you're experienced with Hudi, give a 1, or if it's not, then give a 0. Okay, we have 1 0 0 1. Cool. Okay, so I think most of the people here are giving 0 apart from Harika, right? So yeah, so you're in the right place. So we will be starting this as a Hudi 101 webinar or a meetup. It will be going from the very base, and we'll be looking into some demo, right? Cool. So let's get started. Yeah. Just a minute. Oh, okay. I need to rejoin as it is asking me for some permission. Just be back.
By the time, guys, you can share your expectations regarding this particular session. What would you like to learn? Either it is Hudi basics, or you want to cover you want us to cover a very specific topic. Although we have some agenda for this particular meetup, but we'll try to include your topic as well. So by that time you can share your topics as well.
Yeah, sorry about the glitch. Let's get started. Is my screen visible? Hello, can anyone confirm?
yes sir, your screen is visible.
Okay. Yeah, thanks. So where I can hide this. Can anyone help me with this? Hide floating. Okay, cool. Yeah. Okay, so this will be the agenda for this meetup. So we'll be starting with what is a lake house, right? Because Apache Hudi can help us build a lake house, right? So we'll be looking into first what is a lake house, then we'll be looking into what Apache Hudi actually is. Then we'll be deeping dive into Hudi and figuring out what are the different type of tables available in Hudi, what are the different query types that are available, what are table services that Hudi offers, what are the kind of indexing does Hudi offer. Then there is then we'll be looking into Hudi DeltaStreamer, which is a out of the box a processing utility which Hudi offers you, right? We'll be looking into that, and then we'll be looking into some basic hands-on with Hudi, how you can do your day-to-day operations via Hudi, right? So let's get started. Now, if we have to see how our data platform has evolved from early 90s to 2020s, right? So this is the very good analogy you will get, that at the first during the 90s there were data warehouses, right, wherein the data is brought from different operational data sources and dumped into one central repository kind of place. Here the data would be in a structured format, and then over those data you will be doing your BI and reporting, right? So this is the way that data houses were done actually. Now coming to the second generation, where data was exploding, and that was the time when big data came into picture, machine learning came into picture, and the data size was huge, increasing humongously. And then there was a bottlenecks on those data warehouses, so people migrated to a much more scalable and cheaper storage kind of solution, which is data lake. This data lake can be anything like a HDFS, Amazon S3, or Google GCS buckets, right? It can be anything. So this data lake can store structured as well as semi-structured and as well as unstructured data. And then once you have the data there, you can tune in any of the processing engine like Spark or anything, right? And you can create multiple ETL pipelines, or you can create your downstream data sources, like maybe it can be a data warehouse as well. You can do a lot of things, machine learning, BI reporting, and this was the data lake for us. Now the third generation is more into data lakehouse. So as you can see, it combines both the worlds, right? Lakehouse, if you see, is a combination of data lake plus data warehouse. So what it does is that it brings the goodness of both the worlds, right? And hence we get data lakehouse. So if I talk about goodness, what are the goodness in data warehouse? So in data warehouse, we used to get the transactional reliability, basically your ACID properties. But in data lakes, there was no transactional reliabilities, right? Even if you have to do any kind of transactional operation, you have to maybe first override the data, like delete the data first, and again write the data back. So such kind of operations were very difficult in data lake. So what is a data lake house, right? So as I said, lake house is a combination of data lake and warehouse. So it includes goodness of both the worlds. So let's see what are the goodness that we got with data warehouses. So in data warehouses, the data was clean and structured, right? Because it was structured data, it was into rows and columns, so it was very clean and structured, right? So nothing much messy was there, right? And then we used to get transactional reliabilities, which I have already spoken about it. Then the efficiency of queries that is to run, that was very much faster, because there are a lot of things like indexing was there, push down predicate was there, such kind of things were there in data warehouses, right? Now let's look into data lakes. What data lake has to offer? Data lakes actually gave a massive scale to us. And the cost was very cheap, and you can store tons and runs of data at a very marginal cost, right? The data was into open formats like Parquet, maybe JSON, maybe CSV, whatever suits your organization. That format is open. You can store it in that format. And the kind of workloads that is done into data lakes is mixed. Like you can have a batch pipeline, you can have a streaming pipeline, you can have AI ML pipelines. There can be a mix of loads, right? So now consider Lakehouse to have all these properties, right? So basically, to create any Lakehouse, you would need a low cost storage, right? Anything like S3, SDFS, or whatever you feel like is good with your organization, is your organization already using, and you can go ahead with that particular storage bucket, right? And you need a processing framework along with it. So to process the data that is stored on top of those storage bucket, like it can be Spark, it can be Presto, Trino, anything, right? And one other component that you would need along with storage bucket is a table format. So a table format, we'll be looking into it. What is a table format? So you have that's an extra layer or a transaction layer on top of your cloud storage buckets, which enables you to create a lakehouse, right? Now let's look into what is a table format, or rather first look how a lakehouse looks, right? So here, so a typical lakehouse, it has, it has layers in how you store and maintain your data, right? So I'm taking, it's a standard thing you might have seen across the internet, that the data is into bronze, silver, gold, right? But it doesn't have to be only in this format. You might, if your business requirement suffices with 2 layers, you can go ahead with 2 layers. If your business requirement needs 4 layers, you can go ahead with 4 layers, right? Idea is not the numbering of layers, but idea is to have separate concerns of the layer and how you arrange or segregate your layers, right? So in the first layer, this layer is called as bronze. Here you basically stored your data as is. So your data might be coming from Kafka. It might be coming from some IoT devices. It is throwing some any information to you which you want to get logged. It may be a log-based information, or it may be a CDC kind of information which are coming from your upstream sources, and you want to dump your data as is in the bronze, right? Then once your data is in the bronze, you incrementally keep processing your data. As and when this data is coming to bronze, you incrementally keep processing your data and create a more fine, a more fined version of this data, wherein let's say you attach a schema, right? Or you flatten your data, or apply some business level filtering, or null checks are applied here, data quality checks are applied here, and you basically create some kind of cleaned version of your data, right? Post that, now is the time for, in the gold layers, you can normally create your BI core tables or the business level aggregate tables, wherein you can let's say there's a BI table which uses the silver tables, and it has to join with 10 to 12 silver tables to give a analytics output, right? So rather, what you can do, you can again do some scheduling pipelines which can join those 12 tables, 10, 12 tables, and create a gold table for you, so that analytics folks doesn't have to query that particular complex query again and again. Rather, it can directly access your gold table, right? So which is already pre-populated by you, and this can be like a daily, like a daily the batch job which you can schedule, or an hourly batch job you can schedule as per your needs, right? So this is how a lakehouse looks like, right? Now what are the motivation why you should actually build a lakehouse, right? First thing is serverless. So to build a lakehouse, you don't need to attach any servers upfront, right? Like with Hive or something, if you have worked with, that, right? You have to allocate your servers upfront, and it will, and you have to start paying for them, right? So Lakehouse is serverless. You don't have to allocate servers upfront, and then you get the transactional reliabilities over lakes in a Lakehouse. There is no vendor lock-in. Let's say you are, for an example, if you're using any data warehouse, you get logged into that data warehouse, right? It's not open source, and you'll be only using those tools and technologies which supports that particular warehouse as a source or a sink, right? Now with Lakehouse, there is no vendor lock-in, because your data is in GCS or S3, and the underlying data is in is in open standards, which brings me to point number 3. So your data is in open standards like Apache Parquet, right? Apache Avro. So these are kind of open standards that you get in the market, and you can plug in any of the querying engine that are like open source, like Presto, Trino, Spark. You can do anything that your organization feels comfortable with, right? And then the storage and the compute is decoupled. So if your storage is increasing, you can increase your compute, right? Or or maybe you don't need to keep a high compute at all point of time at any 24 hours. You don't need to, spin that high compute. Maybe during your peak business hours, you can scale up your compute, and during your off business hours, you can scale down your compute. So these things are like totally decoupled from each other, which gives us a lot of cost saving benefits as well. And there is no data staleness, but this is debatable, right? It's upon how you tune your pipelines. You can tune your pipelines to ingest data every 5 minutes, 15 minutes, or you can say, no, I'm fine with staleness. I can go ahead with 1 hour of staleness, right? But Lakehouse gives you that fine control that that you can tune in, right? It can give you minutes of latency. Now you get full support of AI and ML, because you are using those amazing frameworks like Spark, which has very good capability of AI ML, and you can use them to the fullest. Right? The Lakehouses brings data quality and reliability, as I have been taking, because you process your data incrementally, and during those incremental phase, you can apply schema validation, null checks validation, and you can, and maybe whatever is like passing through your validation, you can dump only those data into silver layer. And if it doesn't passes through your schema validation or null check validation, you can dump it into a different different location, which is not part of your silver location, which is kind of a quarantine location, you can say. Yeah, so I would like to take a pause here if there is any question till here.
I would like to know, like, how are these formats which you mentioned, that is the Hudi table, etc., how are they linked with Lakehouse?
Yeah, good. I'm coming to that in my next slides.
Okay, sure.
Is that okay? Yeah.
Surprise, I have a question actually. Hudi supports what kind of file formats? For example, Delta Lake supports only Parquet. Similarly, do you have any constraint on the supporting file formats from Hudi?
Great. Yeah. Just in the next slide, sure. Both of your questions will be answered, right? Okay. As you can see, right? So Hudi or Delta Lake or Iceberg, these are the at the moment. This is July 2023. At the moment, it is in the market. There are 3 available table formats, which are Delta Lake, Hudi, and Iceberg, right? These are nothing but their underlying file formats or the data formats is still Parquet. Delta Lake uses Parquet. Hudi also uses Parquet, right? Hudi also supports ORC. It's in 90% of the scenario, people uses Parquet, but Hudi also supports ORC. But I even me myself doesn't have experience of using ORC with Hudi. So I too use Parquet, right? Hudi also uses Avro. So depending upon your table types, it uses different data formats, which I will be talking into the upcoming slides, right? So now there was a question that how does Hudi converts a data lake to a data lake house, right? So as I've said, right, in data lake, there is no transactional capabilities, right? Say I give you a CSV file in a data lake, and I say you, let's say there is some records like student ID 123, student name Alice, and she got marks, let's say 50. Now I place this file into a GCS bucket, and I say you update that file using SQL, right? So do you think there is any way via SQL you can update a CSV file or a Parquet file in data lake, in GCS or in S3? The answer is no, right? You cannot update it. But now if I say you that, okay, I will introduce a different kind of file format, which is Hudi, right? And Hudi's internal file format is Parquet, so it's okay for you, right? Now I write the data into Hudi format and say you to update the file. Now you can easily do a update via Spark or SQL, because your underlying file format is Hudi. So Hudi is nothing. If you see in the right side, you have a cloud storage, right? On top of this, there is a Hudi layer, right? Hudi, as I have said, is a combination of files and metadata. Files is your Parquet files, right? And metadata is some metadata stored as JSON metadata or Avro metadata. You just ignore it. It's considered as metadata, maybe some JSON format, and there are some transactional log. Combination of this, you get a Hudi table, right? So does it answer your question?
One more thing, like you said that we will not be able to update the file which is there in GCS. Suppose I read that file into a table, and what I do is that I create like I'm having a new table also. Like I will create a replica of that table, and I can do a row numbering, and I take the latest record and I resave that file. Won't that be possible that I will be able to update that file then?
So yeah, I mean, you are doing some override kind of operation there, right?
Yes, yes.
First you are reading the file, then deleting the older file, and again inserting a new file.
Yes.
Right?
Like we
Yeah.
do in normal tables, we can create table on top of that GCS bucket, and then we
Understood.
overwrite that file.
Yeah. So that's the way of doing things in the data lake, right? Let's say if you are doing some operation and you want to update some things, right? So obviously you have to first delete the data and insert the new data, right?
Yes.
Right. Now consider a scenario where you are about to do your updates. You read your data from GCS, right? You did some updates, right? And you gave the command that spark.write.override, right? So what does Spark do? First, it will delete the data, and then it will write the data back, right?
Yes.
Now imagine a situation where the job is running, the delete happened successfully, and during the write it failed. Now what will happen? You are in an inconsistent state, right? Your data is lost. You basically lost your older data as well, and you don't have your new data as well. And again, you have to replay your pipeline again to write those data back again, right?
Yes, yes.
Correct. So, but
yes.
Hudi, but with not only Hudi, but with table formats, right? It maintains ACID properties. It gives you atomicity, isolation, consistency, durability, right? So these are the basic database concepts, right? So it will not, it will write a new transaction only if a transaction succeeds completely. Then it will only, it will remove, or it will remove the older data, I would say, in a simple words.
Okay. Okay. So it won't delete the data before, like, if it will complete the complete operation. If it is not completed, then it will revert.
Yes, correct. So what it does is that if I have to just give a two-liners answer of this, let's say older one, I have Parquet file one, file one.parquet, right? And there is a metadata information which stores the current or the active file. Now it is storing the information that file one.parquet is my active file, right? Now let's say in your update next operation which you are doing, and it's update, the data is getting written as file 2.parquet, right? Once it succeeds, the metadata will get updated to active file is Parquet, file 2.parquet.
Okay.
Right. Now when your readers read it, it will check the metadata first. Oh, what is the active file? It will check that, oh, active file is file 2.parquet, not file 1.parquet. So it will not read file 1.parquet, and it will only read file 2.parquet.
Okay.
Right?
So
that's
will
a happy
that file
case.
1.parquet be deleted?
Will be deleted after some time. There's a process like cleaning process which cleans out your dangling files.
Okay. Okay.
Yeah. And if your transaction fails, that active file will still point to file 1.parquet.
Okay. Okay.
And in that case, file 2.parquet will be removed by cleaner.
Okay. Okay.
Yeah. Okay. So table format allows us to interact with data lakes as easily as we interact with databases. So you will think that, oh, maybe I'm interacting with a table, right? Using a favorite programming language or for big data framework. Right? Yeah. So now let's look into Hudi. We will be talking about a lot of Hudi things. So what actually Hudi is? Hudi
is it
stands
okay
for
if I
Hadoop.
ask a question?
Yeah, sure. Go on.
Yeah. Sorry to interrupt. Yeah, I'm just curious why these are called for table formats. Anyway, without even SQL, we can operate it by using a plain programming language APIs. Whatever languages are implementing these API specifications, is there any reason why they are called for table formats, open table formats to be specific?
Okay, because of the properties that it gives. Like if you consider your database tables, right? That those gives you acid compliances, right?
Yeah, right.
Atomicity, consistency, isolation, and same does your these things. These transactional layers or these iceberg, Hudi, Delta Lake you see, this also gives you the same feelings of working in a you will feel like you are working in a DBMS table, right? So that's why it is known as table formats.
Yeah, absolutely, yes. Okay. But besides that, we can simply, operate on a file level basis as well using the APIs of programming languages. Yeah, fine. Anyway, since this is a special kind of thing, probably that's why they are called table formats. This is a specialty of this, yes. Okay. Thank you. Thank you.
Definitely. So if you don't want to go with the harder way that I was explaining earlier, right, like override and then again insert it back. So if you don't want to go with the data lake approach, then you can insert, you have the opportunity to include a table format in your architecture.
Okay. Perfect. Thank you very much. Thank you.
Good. Thank you. So yeah, as I was saying, Hudi stands for like Hadoop, upsert, deletes, and incrementals, right? So upsert, right? Upsert, update plus inserts, upserts, then deletes is possible, and then incremental processing, right? And these aren't possible with like in a vanilla flavored data lake. You cannot upsert data; it's very hard. You cannot delete data; it's very hard. Like imagine something like a GDPR comes in, and you have to do a lot of a lot of work actually to do some deletes from a HDFS kind of location. So I think Hudi was the first file for or table format, which was started by Uber in early 2017, right? And then on, Delta Lake came into picture, Iceberg came into picture. Soon these things also came into picture, but Hudi was leading the Lakehouse journey. Hudi was actually leading the Lakehouse journey, or they at that point of time they were simply saying that Hudi brings transactional capabilities to data lake, and then in early 2020s, Databricks actually named it as Lakehouse, right? Yeah. So yeah, as I was telling about, I won't repeat. Hudi brings transactional reliabilities, record level updates, and then incremental processing. So you have the opportunity with Hudi, you can keep incrementally processing your data. Let's say whatever data you, let's say there's a data at 7:30, and your last time your Spark job ran at 7:15. Now when your Spark job runs, it can incrementally keep pulling the data which has been ingested from the time it has last processed, right? So benefits of Hudi, there are a lot of index supports actually. So if you see the reason behind why databases are so faster, because databases have indexes, right? A lot of indexes are there in databases, right? So the indexing supports you will get in Hudi as well. You get the time travel phase.
Like indexes are not possible in a Lakehouse system. Sorry, in a data lake.
Yeah.
Are indexes possible in a data lake?
No. How will you index your files there? You will need some metadata, right, to index your data, if I'm not wrong.
Like if I say that my underlying data is stored in GCS and I'm creating a Hive table on top of it, is indexing possible there?
Hive table, right? Yeah. Again, your data is in Hive, right?
Yes.
So Hive might have its own indexing, but consider your data is in S3 or something, HDFS S3. Then I don't think indexing is possible.
Okay.
Hive is a warehouse, right? It's a data warehouse. Hive is a data warehouse, so it will have its own indexing.
Fine, got it.
Then again, the second feature is time travel. So you can always have that flexibility to check the data which was there in past. Let's say I can check the data, like what was the state of my data like past 2 hours ago or 3 hours ago. Until the cleaner has not cleaned my files, I have the opportunity to look back to the files which was there in my past X hours or day, whatever. Right? And it supports all of the storage formats. Like these are the common ones, and I think it supports Alibaba and other cloud storage as well. So there are some. The fourth point is that there are some managed services, the cool managed services like cleaning, which I've been talking about. We'll look a bit into next slides. Then there's clustering. If you are familiar with Big Data World or Hive, right? So you know about clustering. It's like grouping that common data so that in co-grouping your common data, right? Then there's compaction. We'll be looking into next slides. And there's support of schema evaluation. So today, let's say you have 3 columns, and then next day I can increase one more column, right? And Hudi will like work phenomenally good. It won't be complaining anything, right? It will, that support is there like out of the box. Some supports are not there, like reordering of columns is not there. You cannot reorder your columns. You have to only append your new columns, right? You have to only keep adding them at the end, right? So yeah, so you can there is a complete schema evaluation doc in the Hudi official site. You can look into it. So because of Hudi now is not only a table format, it has so many things out of the box that Hudi has started evolving itself to a platform, right? Like Kafka did, right? Kafka started as a pub sub, right? It was just started as a messaging queue. Then it started building so many things on top of it, like K-streams, KSQL, Kafka connectors, that it has turned itself into a platform. Same with Hudi, right? And there is one more thing, like a Hudi DeltaStreamer, which is a wrapper of a Spark job, which I will be talking, in the further slides. Now, this is the Hudi platform at a very high level. So if you see the center here at the center, so you have your data layout, right? On top of this data layout, you have your data files, which can be Parquet or Avro, whatever. Then you have something known as sorry, my bad. You have your base files, right, which are Parquet, ORC, or whatever. Then you have some delta files. In the next 1 or 2 slides, we will be looking into what is a delta file actually, right? Then there are indexes, like a primary index, a secondary index, and the indexes are there. And there is transactional logs over there, right? These transactional logs essentially keep storing the information of each that it has done in each of the transaction, right? Whether it has done an insert, update, whatever, delete maybe. So these are the logs that is there, right? And beneath there is all table services like cleaning, compaction, and these all services are there. And of course, like Hudi has to rely on a meta store, like typically the Hive meta store. So all the table gets registered in the Hive meta store. So your Spark or any querying engine will first connect to your meta store, and then your meta store will provide the path of the Hudi table, and then it can go read the Hudi data from the GCS or S3 location, right? So your querying engine will connect to your meta store. That's how the lines are placed here, right? Yeah. Any questions here? Cool. Going ahead, right? So these are the so this is the transactional log, or the timeline I was talking about. So Hudi has a very comprehensive type of information which it stores in a server known as timeline server. So what it does is that it maintains all the timeline of actions that it has to perform, or it has performed at any instant of time. So typically, there will be an instant action. The type of action, basically, simple words. It will store the type of action, what it has to do, then instant time, at what instant it has done, and a state, right? So the key actions, if you see in the image, so they are like commits. So if you are committing any data or inserting any data, it will, in the timeline server or in the timeline path, right? There's a dedicated path it is to maintain. It will store, let's say, timestamp to current timestamp and dot commit. So at this timestamp there was a commit, right? Or when there is a cleaning operation, it will store the timestamp with dot clean, right? So these are the information that Hudi maintains, so that if anything goes wrong, or if it has to roll back, right, it can look into those commits or delta commits or compaction. It can work accordingly. Now if you see here, there is a save rollback kind of operation as well, right? And there is a save point kind of operation. Save point is basically, if you run a save point job, what it will do, it will save point your data at that instant of time, and it will make sure your cleaner doesn't cleans the data till that point. So your data is intact till there. No cleaner will clean that job, and then you have the ability to roll back to any save point you want, right? In case of disaster recovery or anything goes wrong, right? So it provides all the, I mean, say, it is just like a database, what you can assume. Then there are some states. Your data will be in such states. One state is requested. This will appear, let's say, for a scheduled activity. Let's say you are scheduling cleaning every 2 days, right? So there will be a state where it will be, it will be like, like 3rd of July's timestamp, and there it will be like a requested. So Hudi will keep checking that, requested, keep checking the timeline server, and when it finds that, okay, now is the time for that request to go live, it will execute it, right? Then there is an in-flight state, which basically denotes that a current activity is going on, like let's say a commit is going on. So it will indicate that, okay, commit one.file in flight, right? And if it succeeds, then commit one dot completed, basically denotes a completion of an activity. Yeah. So there are 2 types of tables in Hudi actually. One is copy on write. The other one is merge and read. So with Delta Lake and Iceberg, with Delta Lake at least there is only copy and write. Iceberg recently published merge and read in this year, right? But Hudi was having these 2 things from a long time. Copy and write, what it does is that it stores columnar file, right, in example Parquet, and rewrites the file after each write operation. So let's say I have a file of 100 MB, right? And there, I have a lot of records, and the file size is 100 MB. Now I want to do an update, and I want to update 2 records only. Only 2 records I want to update, which 2 records is like 1 or 2 KB, right? But what it will do, it will recreate the entire 100 GB file with that updated 2 columns. Those 2 columns will be definitely updated, but it will recreate those the entire file. So that is basically copy on write. With each write operation, your file will be exactly copied, right? So I'm not saying that it will copy your, if there is hundreds of files, it will not copy hundreds of files, but whatever file is eligible, right? Let's say there is 5 files in your directory, and those 2 records which you are trying to update lies in file 2 and file 3. So what Hudi will do, it will replicate file 2 and file 3 once again, right? And then older file 2 and file 3 will be cleaned by a cleaner. That's a separate thing. But yeah, but that is copy and write. Merge and read is basically what it will do. It will not create a new file version. Rather, it will create a delta file. So those 2 records, right, which I tried to update, will be created as an Avro file, right, will be created as alpha, and those the file size will be, let's say, 2 KB or 3 KB. So that is like a it will not replicate the exact the base file. It will rather create a delta file, right? So stores the data using combination of columnar and row based file. Updates are logged to delta files and later compacted to produce new versions of columnar files. So there is a process known as compaction. If you have seen the table services, now this compaction services is only applicable to merge and read tables. What this compaction does, so let's say you can schedule your compaction at whatever point of time you want. So whenever this compaction job runs, it will combine those small delta files, and then it will create a larger base file for you, right? And then once the compaction is done, those delta files will be cleaned by the cleaner. Right? Now there is some trade-off between this. So obviously, the data latency, right? If you talk about data latency, see, on copy and write, it will be higher as you are rewriting your data again and again with each write operation. So your data latency will be higher. A merge and read will be very lower. So if you have some, pipelines which needs to ingest data at a very high speed, go with merge and read. Right? It will just keep on appending the data, and then it can be compacted at any point of time. You don't care about it, right? So then for those use cases, you can go with MOR tables. Now query latency, if you're now obviously merge and read has to do a lot of things if you are querying it. Let's say I'm querying select star. So what it has to do, it has to again combine all those small files, right, and then give you the final output. So the query latency time increases rather than copy and write. Copy and write, you directly query on the base file, right? Then is the update cost. Update cost is obviously higher because you are rewriting the entire Parquet file. Merge and read is lower because you are only creating those delta log files. The Parquet file size is smaller here, and then but on merge and read, your Parquet file size will be higher because your data will be at last combined, compacted, right? And write amplification is also the same thing as writing the data. It will be higher. Too much of writing is there, and in merge and read, writing is less. Any doubts here?
I have got a question, like we can use Spark in order to write our data in Hudi file format. Like we do
Yes.
spark.write. And then we can give the Hudi file format, and all of this is handled internally.
So spark.file.format Hudi, and then you can give your path, and then there's a bunch of Hudi configuration you need to set, like file spark data frame.write format this one, then config, and in configuration you have to pass a configuration object, which is the part of the demo I will show.
Okay, sure, got it. And there we can specify that we want it to be copy on write or we want it to be merge on read.
Exactly.
Okay.
You can, yeah. Cool. Any other question? Okay. So next thing, as you can see, right? So I will show that how copy and write actually performs. Let's say this is the first batch coming at TS1, timestamp 1, right? Where I have key 1, key 2, key 3, key 4 are there. So let's say my Hudi decided to create 2 files out of it, right? There is a separate process known as file sizing, which will take the this decision on it. But I'm not going into so much depth in today's session. So let's say it decided to create two files. Key 1 goes here, key 3 goes here, key 2 goes here, key 4 goes here, right? And then as you can see in the commit timeline, it will be like a commit 1, and this is in flight, right? So the commit is going on. It is in flight. Once the commit succeeds, it will be marked as done or committed, right? So this is intact now, right? Now a separate version, let's say at timestamp 2, key 1 and key 3 came with an update, right? So this is, since this is copy and write, so key 1 is in this file and key 3 is also this file. So this file will be again rewritten with values C1 turned to C2, C1 turned to C2, right? And this file is untouched because updates didn't came for this file. So this file is untouched, right? And even if it came for one update, said only one key one, let's say it came for key one, then also it would have written the entire file. That's how copy and write works. Merge and read. This is the same left side is same, right? But in right side, let's say key 1, key 2, key 3 came with an update. It didn't override, it didn't create a new version of the file. Rather, it create a delta file, a small delta file, right? And this will be merged to the base file once the compaction job is run. Cool. So cleaning, I think we have already talked about it. Cleaning, you can schedule it synchronously or asynchronously, right? Synchronously, you can sync in a streaming job where it is continuously, continuously writing data, and you can mention that, okay, let's say every 10 commits, after every 10 commits, you clean the data, right? Or every after 2 days, or you can, let's say in minutes, right? Two days, say you clean the data. Whatever is dangling, you clean it. Similarly, clustering makes data very much read efficient for your queries because it groups the related files or the related data together in the file layout, right? So this can also run synchronously, asynchronously. With synchronously, you have to schedule a different job for clustering to happen. But in asynchronously, you can just mention that, okay, after 4 or 5 commits, I want to run clustering. Right? Typically, we keep it higher, like above 10, because it has to again rewrite all the Parquet files from here to there. So clustering is a costly operation. Then compaction.
I have a question actually. Sorry to interrupt.
Yeah, sure.
Here, Hudi is actually just a file format. In that case, if suppose if we mention that for every 2 minutes run the clean operation, then it actually indirectly tells that there must be a server running in the backend, which is not the case. Then how it is actually getting done? If you please explain.
Okay. So basically, there is this timeline server, right? Hudi Timeline. Now it's this responsibility of your Spark job, right? Your Spark job will actually, when it is running, and you mentioned that you clean the data every 2 days, right? The Spark job will look into the timeline server, right? And if there is anything eligible to be cleaned, which is in requested state, if it is found that, okay, some data is there which is in requested state and it has to be cleaned, then it will be cleaned. Because there is a timestamp attached. When this timestamp will be eligible, let's say today's first, there's a timestamp of 3rd July, right? Since the Spark job is running continuously, right? And when the timestamp comes like 3rd July, so and so on time, and it exceeds the timestamp or is just equal to the timestamp, this will be clear. This will be kicked in. This job will be kicked in. Cleaning job will be kicked in.
All right. So only if the Spark job is actually a streaming job, then only it would be done. So if it is a batch job, then whenever the batch job hits and if the given conditions are met, then the clean operation would be triggered.
Exactly. With batch job, you won't. There is no something like requested or something that will be not there. Whenever you will schedule it, it will clean older files, dangling files.
All right. Then it may not be not necessarily the Spark jobs. When other processing frameworks also hit, for example, Presto or Snowflake, then also all these things would be done. Cleaning, clustering, whatever you mentioned. It's not tightly coupled with Spark, right? Whatever processing framework. Yeah.
No. These are not supported by Presto, Spark, or something. Cleaning, clustering are supported by Spark Flink only at the moment with Hudi.
Oh, right. Okay. Thanks.
Yeah. Your Spark, Trino, Presto, these engines can only query your data. It cannot manipulate your data.
Oh, right. So for manipulation, only Spark is supported from Hudi.
Spark and Flink.
Oh, Flink. Okay. Got it. Okay, thanks.
Okay. Then comes archiving. What it does basically, it moves older Hudi metadata files. So there can be a lot of metadata files over the period of months or years. So what this archiving process does is that it keeps moving those metadata files into a different location. So it moves older Hudi metadata files that are no longer being used from the metadata's timeline to an archive log. So otherwise your metadata's timeline log, right, will be increasing drastically. So whatever file is, so whatever the metadata is not required, it keeps on moving them to our different archive location. Let's say there was information of student marks got changed from 30 to 60, right, and then 60 to 90 or somehow, right, and then those information of 60, the older states like 30 and 60 are not been used, are no longer been used or something. Then those information or those metadata information will be moved to an archive log into a different location. So this is archiving of moving that older or non-required metadata to a different location. Right. Now comes query types. So there are 3 types of query types. Again, first 2 is applicable to a lot of querying engine, which you can check in the support matrix graph. But incremental queries on date is supported only in Spark and Flink. Right. So the first one, snapshot queries or the real-time queries, is what it will do. You will see the latest snapshot of the data. Given any commit or compaction, it doesn't care. It can read all the data. So in case of MOR tables, what it'll do, your snapshot tables will merge those delta files with the base files on the fly and give you the result, right? So this will be a time-taking query because it has to merge those delta files as well, right? And in case of COW tables, if your table is COW table and your query type is snapshot query, it will only query those base active query files, Parquet files, right? Yeah. And the other one is read optimized queries. So read optimized queries is in case of MOR tables, it will only it doesn't matter whether your file is MOR or COW. It will only query your active base files. It will, in case of MOR files, it will neglect your delta files, right? So that is, it is read optimized, right? It doesn't care. In case of MOR files, you will be losing some latest information because your latest information is still in delta files. It is not bothered about those latest information. So if your analytics team or if your downstream team, right, is fine with few hours of latency or delay in seeing the results, you can go with read optimized queries, right, where the processing cost will be slower, right? But if there are critical use cases for like any payments kind of information or something like very critical information, then you have to bear the cost of real-time queries, provided your table type is MOR. Otherwise, it's the same thing, no difference. Incremental queries, as I have seen, yeah, go ahead.
So sorry, if we are reading in read optimized format or in any other format also like snapshot, so this commit time we have to give.
Commit time, where did I mention?
Like you are saying, na, given commit or compaction action. Like if I'm reading a table, so I have to give that commit time.
No. This is not commit time. Commit of a table. Let's say the latest commit happened at 8 p.m. Right? And if your query runs at 8:10, so it will see the latest commit. That is in 8 o'clock.
Okay.
You don't need to pass on anything. It will see the latest commit by itself. Latest commit or compaction. It will figure it out by itself.
Okay. And if suppose I want to read data of some older commit times also, is that possible?
Yes, possible. Time travel is possible.
Okay. So it means that it stores older data also.
Yes, it do stores until so until the cleaning is not done, it will store, as I've said, right?
Okay.
Once the cleaning is done, then you lose your older files.
Okay. So I was just going through a documentation where it mentions there is a Hudi commit start time and a Hudi commit end time.
Yeah.
So what does
Yeah.
that mean here? Like, what is the
The
start
time at
and-
which the transaction started, right? And the time, Hudi end time is a time at which the transaction completed.
transaction as in like I have got a
Like a
table which is
batch of data you are writing.
Mm-hmm.
There is a batch of data. Let's say it's a Spark job, Spark structured streaming job. There's a micro batch you want to process. Then this, when this micro batch started writing, right? It is the Hudi start time, and when it completed writing, that is Hudi end time. Yeah.
Okay. And does that make sense while reading also? Like this was like when I'm writing, I get to know that what is my starting, what is my end time. But how does it help me while reading data?
For what context do you need what time I have to read the data? Not able to get your question actually. Maybe we can discuss at the end of the session.
Sure.
Not to deviate. Yeah, thanks. Yeah, then incremental queries, queries will only process the data it has newly seen from this last commit. It maintains checkpoint kind of information. It keeps on maintaining checkpoint information or the commit information. So if there's any latest information it has not seen, it has newly seen, it will only pick those data. But this is only applicable to Spark and Flink, right? And yeah, so you can definitely leverage this incremental data pipelines. Now there are some key types because of the demo. I have to make you understand this key type. So like every RDBMS tables has a record key or a primary key. So Hudi also has a primary key, and it cannot be null, right? Then there is then there's pre-combined key, which is something different here. Pre-combined key helps you to get the latest value. In case where you get multiple records for the same primary key, pre-combined key will help you to get the latest one. Let's say there's a batch of information. In a batch of information, a student's marks has been updated thrice, right? Let's say 8.1, 8.3, and 8.5, right? And I choose to make the timestamp column as my pre-combined key. So whatever value came at 8.5, I will only pick that and discard the rest too, right? So that's pre-combined key, which helps to get the latest value if there are multiple records coming for the same primary key. Then partitioning key, I think you all understand. This key is used to ensures that records belong to the same key goes to the same partition. Then again, there is clustering, which ensures that records belonging to the same key value are packed together, right, within the partitions. So these are the 4 types of keys that you get in Hudi, right? Let's go ahead. Now there's comes indexing, right? There are lots of indexing. I'm not going into depth of it, but just want to give it a gist of it, right? Basically, now you can think that, okay, how Hudi identifies that in case of this one, right? This example. So you might be curious that, okay, how did Hudi figure out that, oh, file 1 has to be updated, not file 2, right? Because key 1 and key 3 are placed in file 1. So how did Hudi figured it? So Hudi actually figured it with the help of indexing. So like indexing of books, right? If you want to go to any particular topic, you search the index and you directly go to that page number, or so to that page. So similarly, Hudi does. So indexing is used to identify which files have updates, right? With indexing, the incoming updates are batched, are mapped to files which has record keys. So what it can does, it can simply look into that, okay, which files are eligible for merging, and so the merge cost is less. Otherwise, if you see the images now, since there is indexes and you have a file of 100 MB, and your updates, each updates is of 25 MB. Now each 25 MB updates are simply merged with this base file of 100 MB. And if there is no indexing, now each update has to go to each of these base files and check whether he is eligible for merging or not. right? So the merge cost is double here, right? So that is the difference of having index and not having index. And if there is no indexing, then each new incoming updates has to be checked against every existing data, right? And turns out the merge cost to be high. Yeah, any doubt here? Yeah, so this is like a pictorial representation. So for, as you can see, right? So there is this batch coming in, right? Let's say this is the first batch where there is key 1, C1, key 1, this is there. And then batch 2 came at timestamp 2, right? So the indexing happened, right? And it got allocated there, right? And so it decided to create 2 files out of it. So for each of these incoming keys, it will look into the existing tables index metadata information and figure out where the keys belong. It tags the incoming records with the location information of the data files. Any question, doubts here? Okay. So now there are some operation types you need to look into. One is upsert, then is insert, bulk insert, and there is delete. Upsert is the default operation. So what it does is that first tags as inserts or updates by looking to the index. So if the index has not been seen by far, then it's an insert operation. If the insert index already exists, then it's an upsert operation. It tags it as upsert operation, right? And this table will never show duplicates. And this kind of operation are best suited for CDC use cases, right? Then next is the insert. This is very similar to upsert, but what it does is that it completely skips the indexing part, because it is insert and it will do just append. So your it is much faster than upserts, obviously, because it doesn't have to do lookup or remove or other kind of updates, right? It is just append only, and this table will show you duplicates if duplicates records are coming, right? And then bulk insert is very similar to insert, but its semantics are very similar. But what it does is that if your data is very large, it's in hundreds of TBs, right? Then it's efficient to go with bulk insert, because it does some kind of optimization, like a sorting of the data, right? Based on the data, right? It does some sorting, so your relevant data goes to a code located in the file path. So it does some kind of optimizations. So for larger data, it is best suited. Now for deletes, there are 2 types of deletes. One is soft delete and there is hard delete. So I'm not going to deletes in my demo, of course. Soft deletes is basically setting null for the values. Let's say you want to delete any column, and soft delete will just not delete the column actually. It will just set those records to columns to null. And then hard delete is actually deleting the column entirely from the table, right? So in that case, it will manipulate its metadata somehow, and then it will stop showing you that column while querying it. Now, this is something I think there's 2 more slides, and then we can go to the demo. This is Hudi DeltaStreamer. So Hudi DeltaStreamer is a utility tool, which actually incrementally pulls data from any of the sources, right? So it is this Hudi DeltaStreamer is a Spark application, nothing else, right? And this has to be a Spark application. This is because Hudi DeltaStreamer beneath is a Spark job. It is nothing else, right? And this is 2 modes in how you can deploy it. One is run once mode, that is like a batch mode, you can run it. And other is the continuous mode. It is like a streaming mode. Let's say you give that every 10 minutes you want to run it, so it will keep on triggering every 10 minutes, right? So now this is a kind of a managed Spark job, you can imagine, right? Where you don't have to do a lot of coding or a lot of other things. This is a config-driven Spark job which Hudi is giving you. You can directly use it, like Spark submit, give the jar name, and there's a bunch of configurations that you can pass with it, and just submit it. Your job will be done. Right? Yeah. So there's a details post you can look. So basically, I'll give you a high-level overview. So there are a few phases, like data source, obviously, like the one from where you will read the data. Then your business logic processor. So if any custom transformation or business level logic has to be applied, then you can pass on the jar in this phase. You can attach your jar and it will do your, so the input to this jar will be a data frame and the output will also be a data frame. In between, you can do your transformations, right? Then there's a key generators. Then there's a key generating phase wherein your partitioning key, primary key, clustering key will be set before writing the data, and then your writer comes in. It will figure out the indexing. It will figure out the schema, right? It will do the registration in the Hive meta store, and then finally write the data to your GCS bucket. And then there is cleaning, compaction running, where where you can mention let's say every 2 days I want to do cleaning or not. This you can mention in the DeltaStreamer. Right. So yeah, now we have talked about Hudi, but what after Hudi? My data is in GCS, is in Hudi format. How will I query it? Right. So querying, you can use different kinds of engines, right? You can use Presto, you can use Trino, you can use Spark, you can use Hive, right? So let's say I'm in GCP, so I have Dataproc server, wherein I use Spark for my ETL batch job or data science model. So I use Spark, and I also provision Zeppelin, right, for analytics workload. Sorry. Then for ad hoc analytics, right, I have Presto server. So Metabase or Tableau, these things can connect to Presto, and I can present my data to to analysts, the BI engineers, and all. Right. So according to your table type, according to your query pattern, you have to see what things are supported in Hudi, what not, and you have to decide the framework that that you want to go with. Right. So as of now, real-time, if I have to talk with real-time queries is supported only in Spark, Flink, and Presto. Right. Other read optimized queries are supported by a bunch of other querying engine. Even there is a BigQuery sync tool as well, like Hudi DeltaStreamer tool. There's a BigQuery sync tool as well by Hudi, wherein you can expose your Hudi tables to BigQuery as a read optimized table, of course, not real time. As a read optimized query, you can expose it to BigQuery, and you can query your Hudi data via BigQuery as well. So yeah, so any doubts still here before we move to the demo? Hello, I'm audible?
Yes.
Yeah, cool. So for the demo,
sorry to interrupt, but besides all these frameworks, we can use plain programming language APIs as well, right? For example, from a simple plain Python, if the APIs are available, Hudi APIs are available, I can connect to the underlying storage structure and read data by means of simple API calls.
If there is API, there's libraries, you can read it via, but I don't think there are at the moment.
Oh, really? Okay. Because Delta Lake has. Similarly, I was under that for the other open table formats also have. No. Okay.
As of now, no. Yeah.
Okay, thanks.
I know Delta Lake has via Rust is there.
Yeah, many languages are supporting Delta Lake. Yeah.
Yeah. But Hudi, there is not as
you don't have. Okay, thanks.
Yeah. So here it's a Spark job. I'm using a batch Spark job for simplicity. So the Spark version which I'm using is 3.3.2. and the Hudi version is the latest one, which is 0.13.1, right? Yeah. So I have to include, there is a bundle known as Hudi Spark bundle. So this bundle essentially changes with the base version of the Spark. So if you're in 3.2, you have to use 3.22. If you're in 3.1, you have to use 3.1, right? And there is a Parquet Hive bundle. Basically, this is needed to read the Hudi's internal base Parquet files. Right? So you need two of these dependencies, Hudi dependencies, and yeah, you are good to go in most of the cases. Okay. Now, as there was a question that how do I mention all of this information, right? What is my table type? What is my record key while writing the data, right? So I said that you have to pass a bunch of configurations. So this is the configuration actually, right? So what you do, you create a map kind of thing, a data structure, wherein if you see, I will mention my table name, right? What is my table name? I want to store it by. Then I will mention by record key, right? It is employee ID. My partitioning path will be, I'll partition my data based on age. Then my pre-combined field, right, will be edited, right? So pre-combined key will help you to figure out the largest value if there are duplicates for the primary key. Then my table type is copy on write, right? And then the operation type can be insert, upsert, bulk insert, delete, whatever you want to pass. I'm taking this as an argument. So this is the one. And then index, there are a lot of index like HBase index, simple index. There are a lot of index actually. I'm using the simple one. You have to mention the simple index here. Then the number of shuffle parallelism you want your Spark job to do while upserting data and while inserting data. Then similarly, you can do it for bulk insert. Then you have to mention this parameter here as well, right? So yeah, let's keep it till here, and then we will go to the code. Yeah, till here, any doubts in the configuration? Okay. Then there's some few of the standard things which I need to pass as a configuration while creating my Spark session. One is the serializer. So Hudi only works with cryo serialization. Cryo serializer, it doesn't work with Java serializer. So that's why I have changed the serializer to cryo serializer. And there's two of this configuration which you need to do, which you need to apply, right? If time permits, in the interest of time, I'm skipping this as of now. Yeah, because we're already over time. Then this is my data structure of what I'm storing. I'm storing employee ID, first name, last name, email, age, and editor. These are some of the records I'm storing, right? And then I'm creating the data frame out of it, right? So this is I'm creating a data frame. Now what I will do, I will insert the data. So what I will do data frame dot write dot format Hudi. Then I will call this function. Yeah, I'm calling this function with type of operation as insert, right? And the mode I'm doing is override basically, because as a purpose of demo, I want to execute this again and again. So I am doing this override, right? And I'm doing with a file path, right? So let me check if my data is already present. I will delete it. Yeah, it's not present, so we are good, right? And what we can do, I will, yeah. So let's go and execute.
One question, sorry. Like, if my type of operation would have been an upsert, then I would not give the mode as override, right?
Yes, definitely. Then it will be append.
Then it will be
Append.
append. Okay.
Yeah. You give it as append, rest Spark will figure it out. I mean, my next one is upsert only. I'm just doing the insert first, then we'll go to upsert. So yeah, this is my base data frame, right? So yeah, because edited you will see 0, because let's say I will explain why edited is 0. I couldn't find a proper use case because of some other dependency. I couldn't find time. So edited means, let's say this record is not edited as of now, right? It is the first time this record is been inserted. So in that case, edited will be 0. And if this record got edited, I will give some edited time, right? So if it is not edited, it is first time occurrence and it will be 0. Yeah. Now I have written this file in GCS. Let's go to this. Okay. Yeah. So I have written in this place Hudi, and Hudi inside this is employee. Why it is employee? Because my table name is employee, right? So that's why I see a folder here, employee, right? Now, if I go inside, what I will see? I will see 24, 30, 31, 37, 42. So these are all the age, right? These are the age of this employee, 30, 45. And why it is like in this format? Because I have mentioned that my partition path is based on age, right? Now, if I have to go inside, so this one, then there will be a party file, right? Because employee having 24 age is here, right? And 31 is here. So similarly, in every file, there will be one party file, right? And this is the value. So if I go to my code, yeah. So printf after insert, right? So I'm then after writing it, I'm reading it back, spark read format Hudi, right? And then I'm printing it. So you see here what you get this commit time. At what time this record actually got committed. So this commit time will be here, right? It got committed in 2021 in 24 hours time format. And what is the Hudi file format? It is this one. What is the partition path 56? Because the age is 56, right? So it is also given you this information, right? Hudi record key is the primary key, because primary key was employee ID 4455, because this is the Hudi record key, right? And yeah, this bunch of information looks good to us. What it is we have read, right? Now, okay. Now what I will do? Okay, so this is the reason I was giving it a override. I will run the program and the data will be overridden once again. Yeah. So now what I'm doing, I am now updating a value. So you see John is there, 5, 6, 7, 8, John R. So this John R I am passing as John Robin this time, right? And so that's why I have given this edited time this time, because it's an edited value, it is coming with us with some value. Now these two records got inserted newly, and then again this in the, let's say this is a, you can imagine it's a streaming job, right? Then this micro batch came after 15 minutes maybe, right? And it came with 2 updates for John, right? Yeah, for John, for 5, 6, 7, 8, right? So next update was for John Robinson. Now Robin got, first it was John R, then in here it became John Robin, then it became John Robinson, right? Now the timestamp is, this one is higher, right? 1915, and it is 19900. It is 0915. Okay. Now
we have to
see what.
manually pass the timestamp, or it will get automatically detected.
Sorry.
We have to manually pass the timestamp, or it should get automatically created.
No, this is the pre-combined key. This one is a, let's say your this one, your application is giving you this time. For this use case, I'm assuming your application is giving you this timestamp. If a record is edited, your edited time will come with the value itself.
Okay. Okay.
Yeah, this is I'm assuming.
Okay. Okay.
Okay. Yeah. Now, yeah, there were 2 updates from the application. Let's say one update happened at 09000, and next update happened at 0915. Okay, so that's why in this micro batch, John came twice. Right? Now let's see what will happen. Okay. So just to remind you, there was one Parquet file inside all of these folders, right? One Parquet file. Now it got deleted because, yeah, it has executed in here. Okay. Okay. Let's see what happened for 31, right? See, you got two files because the operation type was cow, copy on write, right? So that's why 31 John got updated, right? And this files got applicated twice. And others, if you see, it is still one because no updates came for any other employee which is having 30. Only this got updated twice. It got updated, so the file got created once. So you have two files, right? Now, if I have to check this, right? Now let's see. Where is John? See, now John got updated to John Robinson. Right? Why? Can you say why John Robin was discarded? Why John Robin was discarded?
Older timestamp.
Older timestamp, correct. But how did Hudi recognize this is an older timestamp?
With this key itself that we have given at the end, right?
Yeah, because this is mentioned as the pre-combined key edited, right? So it has discarded the smaller one. It has only picked up the larger one, right? Good. Good. So one more thing I will say, I would show. Let's say with any updates, right? With any update, I change my partition value. I make it, let's say 99, right? So let's see what would happen. Now you see John Robin and John Robinson both, right? Because your partition path got changed. What happened is that your partition path got changed. Now it went into a different partition. Now your pre-combined key cannot locate this partition. Your pre-combined key works only in a in partition wise, right? So it has gone to a different partition, so it is not able to figure out. So this partition, what it has seen that okay, for 31 John Robin is the latest one, so it has shown John Robin, but John R was discarded because because this value was 31 in both the case. But since this value is changed to 99, right? So it went into a different partition in the directory itself. So you see 99 is created. So pre-combined key didn't work for this case, right? But it will, now what you have to do, you have to enable global indexing for this. Now it is local index. Local indexing is within partition. Now you have to make it a global partition. Oh, sorry, global index. So it doesn't matter where, in which partition it is. It will look for the primary key in all of the partitions. So I have to change it to global simple. And if I run it, now this will be resolved. See, so John Robinson is there and value is 99, right? And the other one got discarded. Now it is applied to the global level. So my latest one is picked up 915. Right. So what would have happened if 99 is here and 31 is here? In this case, what would have happened? Anyone?
A new user with John Robin with 99 partition, and the older one would have been replaced with John Robinson.
If global indexing is not set, then it would be the case. If I remove global indexing, so you will get a new user with John Robin as 99, right? But if global indexing is set, right? So so you won't be getting this. You will only get this one only, because you are looking at, for this ID in all the partitions of your table. Right? That's global indexing. So if I run it, so insert John Robinson is there. This value is there. It's still 31, right? 99 got discarded. Understood?
Yeah.
Now, incremental queries. So for incremental, what I'm doing is that I'm fetching a time. Let's say the time at which the upsert happened, right? Upsert happened when the time for upsert. This upsert is basically, this one, latest employee DL, right? So for so there is two commits, right? One is the initial commit, this one, this commit, right? Base employee data frame, this is one commit, and then the other commit happened, which is this one, latest EMP, right? New EMP. This is two commits, right? So I read this second commit, right? I will read this second commit information, and then what I'm doing, I'm selecting the Hudi commit time, the minimum of Hudi commit time and a maximum of Hudi commit time, right? So what it has given me, let's say, so it has given me some time frame, right? Some time frame it has given me. Now what I want to do, I want to read those data only after a certain point of time. Okay, it has occurred after a certain point of time. For this, what I'm doing, I'm creating a new function. I'm mentioning that my query type is incremental, and you only begin to read after this instant time, right? And then I'm passing a value, right? So I pass this value, right? I have passed this value. So what this incremental query has given me, it has only returned me those records which it has seen after this time. So after this time, what it has seen, it has only seen these 3 records, right? It has only seen these 4 records. So it is only returning me these 4 records should be returned, but this is the same value only 5, 4, 5, 6, 7, 8. So it has given me only 3 values, right? Because the begin time was for this data frame. After this second commits data frame I'm using, right? I have taken the begin time from this data frame, right? Yeah, latest data frame. So it has only given me this 3 records, right? So this is incremental processing. You only process data which you have seen after a certain period of time, right? Here you have to pass your time frame. This depends on certain time. You have to pass your time. That after what time you want to see the data. Right?
Can you give an example of use case where this could be useful? Like, why are we doing this?
Okay, let's say there is a ingestion job, right? Which gets data from like a IoT device, maybe. And every 15 minutes you are you are dumping data from Kafka to GCS, right? So after that, yeah, then you can give a time frame, right? That every 15 minutes, I will only process the newer data, which are or the newer offsets which are coming, which I have not processed till now.
Okay.
Am I making sense?
Okay, so and one more thing, like you are saying you are taking the minimum of Hudi commit time and the maximum of Hudi commit time. Like there is a single time only which we want to say that after this time we want to read all the records. Why there is maximum and minimum commit time then?
Maximum is I have not used yet. It is for different use case.
Okay. Okay.
I don't need actually because this is just an example, man. You can give any time you want, right? You don't have to get it from a data frame. You can pass any time here, and it will pick up if it has seen any records beyond that time. It will pick it up. That's what I was saying. If let's say you want to incrementally keep processing your data from Kafka topic, right, every 15 minutes. So you will pass, let's say, timestamp minus 15, current timestamp minus 15. So it will process all the older records from last 15 minutes, right? Again, 15 minutes will pass ahead, and again your job will run t minus 15. Then again it will read the older data that is 15 minutes in your Kafka. Right? Yeah.
But what does this max and min signify? Like if in my table.
This has nothing to do. This has nothing to do. I have just to pick up some time, right? I am just using this one. This has nothing to do. Yeah.
Okay.
Yeah, I just eliminate this, right? And consider I am passing this one.
And I should always take, in fact, the maximum Hudi commit time only, because that will be the last time when my latest record has been written. Why would I take the minimum Hudi commit time?
Yeah, makes sense. Yes, you can do it. Yeah. Yeah, actually you have to look the maximum commit time only, what it has seen. If you want to processing it incrementally, you will look at the maximum Hudi commit time only. Is that okay? This was just an example, so do not take it. So this I was just trying to explain the concept that okay, you need to give some timestamp, right? And since this was giving me the exact timestamp type, like 13 digits, right? So I picked it from here.
Okay. Okay.
Yeah, this has nothing to do with this thing. But you understood the thing that you need to pass some this one, some begin time, right?
Sure.
Now there is time travel, right? Time travel means you have to give some end time and some begin time and end time, right? So let's say for this use case, I'm giving begin time as this begin time and end time as this end time. So of course, your point in time query will also give me the same result itself, like incremental, right? Because this is the same time frame I'm querying in a way, right? But if I give a timestamp of 000, that is the start of my Hudi timeline server, right? And then I give the begin time, right? Then what should I see? I should only see the records that has occurred till here, right? This much, correct? So if I see point in time 000, this one, and begin time, so you see John R, right? So that's why I took begin time actually for this example. It was just an example, right? For this example, I actually took begin time, but I can put it here, I can put it in there as well. Yeah, doesn't matter. So this is time travel. You can go back at any point of time. Until unless, so let's say after some time I cannot go. If I would have started a cleaning job here, somewhere between, then my older data would have been cleaned up, right? This file, this dangling file, the first file would be the dangling file, I believe, would have been cleaned up by the cleaner, right? Then I cannot do the time travel. Then there is no option. Or I would have to do a save point. I have to do a save point, then my data wouldn't be cleaned up by the cleaner. And if I have to show the Hudi metadata timeline server, there is this .hudi folder.
Suppose in this case, sorry to interrupt.
Yeah, yeah.
In this case, we have a dangling file, which is a stale file. So if you want to clean it, how can you do that? Do we need to explicitly call some function on the Hudi configuration object? Or
yes.
okay.
Yes. So if I go to the Hudi docs, so there will be something services cleaning, right? This is a cleaning job which you can run. Like, you know, if you want to run it synchronously or if you want to run it asynchronously, you have to pass this spark submit master class Hudi cleaner, right?
Okay.
And then you can pass the configs at what point you want to run, right? See, you can keep that. He's saying that, you know, you keep the latest commit. That is like 10 commits you have to keep, right?
Right.
So keep the latest 3 file versions. Keep the latest last 10 commits, right? Latest 3 commits or latest 3 file versions I want to keep. Clean commits older than 24 hours, right? So these are the things you can pass if you are running it synchronously, right? If you want to run it asynchronously, then again you need to check, you know, how within running the job you can find out that how you can pass the asynchronously. So in asynchronously you don't need to run a separate job. I think I have posted a link here. Let me go here. Yeah. So this is continuous mode. This will run like a streaming job. So here, if you see, he have so this job, in this job, since it is running, it is not stopping. This job is not stopping. It is running continuously. So you can mention that every after 20 commits, you clean the data.
Okay, got it. But yeah, I think in one of the tabs there are many other services. All those services are provided as Spark jobs. We can run them as a one-time instance, or we can run it continuously. So it's all possible. Okay.
Yeah.
Okay, perfect.
These are all asynchronously passing jobs. So if you're running, if your commit is going at the same time, and clustering is also going on, so there'll be no issues. This completely runs in isolation. It will wait for the other one to complete, then it will run. You don't need to worry about isolations. Yeah. So yeah, that was all. So if you want to run it as MOR, okay. I was showing you this Hudi folder. So inside this Hudi folder, you will see a lot of options actually. So I was showing the timeline server, right? So see, this one is commit. This one was requested, right? And this one was in flight. So that means the commit was going on. And then 133.303. See, after it has committed, or it was in flight. First it was requested, right? Then it has gone to in flight. It was actually processing. When it is completed, it has gone to commit, .commit, right? So this is how the metadata is been, timeline server has been tracked. There is some metadata files as well, right? And inside each folder also you will get metadata, right? So yeah, this is how Hudi tracks. This is Parquet plus metadata equals to Hudi. So all these things are tracked via metadata files, right? And the last thing is that if you want to change it to MOR tables, just change it to MOR, right? And in this case, you won't get 2 Parquet files in folder 31. Let me show you that very quickly. So So see, you still see a one single Parquet file, and that delta file will be this, this one, a dot delta file, right? It will be a dot file. You won't see two files here, right? This will be merged if you run a compaction. Again, you can find out the configuration how to run a compaction job. It also runs synchronously, asynchronously. So one thing I want to show is that Hive style partitioning, the last thing in today's item. This is something how, once the job runs, then I will show. Basically, this will write your data in a Hive style partition. So your folder's name will be age equals to 31, age equals to 30. So in this format, see, age equals to 24, age equals to 30. This is Hive style partitioning. If you want in this format, you have to add these two configs. Yeah. That's all for today's session. If you have any queries, please let me know.
Okay, so for metadata, Hudi does not use JSON file.
Sorry, can you come again?
I mean, for the metadata, JSON is not used.
For metadata, JSON is not. No, JSON is not chosen.
Oh, okay. So it's not like Delta Lake.
Delta Lake, no.
Yeah. Okay, thanks.
Yeah, it uses different metadata file formats for different purposes, right? But I don't see JSON.
Okay.
There's no JSON. Yeah. Anything else?
Guys, we have shared a feedback form link in the chat. Please do fill your valuable feedback, how we can improve our sessions, what all topics we can include in future meetup sessions. Please do fill out this feedback form. And you will get the recording on our YouTube channel. You can subscribe to our channel on YouTube to get the recording and to get the latest updates. You can follow us on LinkedIn. And if you need slides, then we will definitely mail it to you on your email ID. So yeah, that's it from our side. If you have any questions, any doubts, please do share your questions.
Cool, everyone. Thank you. Thanks for your time.
Yeah, thank you very much. Thank you,
Thank you very
Sarfraz.
much. Thank you very much. It was
Bye.
very interesting. Thanks.
Great. Thanks to you guys for being there.
Yeah, thank you.
On top of time. Yeah. Thanks.
Thanks.